This video is going to cover the 2-4 warm-up and then the review notes for the quiz. Remember that at the end of today's class, you're going to need to submit the work for both the warm-up and the notes for the quiz review all in one document. So again, if you'll pause the video and allow everybody about 5 to 7 minutes to work on the warm-up, and then after they're done, go ahead and unpause the video so that we can go over the answers. Okay, number 1 says use the diagram to write an example of postulate 7. Remember that postulate 7 is not something that you would provide as an answer in numeric form, but you would rather write out what postulate 7 is, which says if two lines intersect, then their intersection is exactly 1 point. So if I look at the diagram that's here, if I want to identify two lines that intersect, I could use these two, and the place where they intersect or the point where they intersect, which is F. So I can write that line E, F, and line FJ or JF intersect at point F. You could also say line N and line M intersect at point F. Number 2 says decide whether the statement two planes can intersect in exactly 1 point R is true or false, and give your reason. So this statement is false, and the reason is because two planes intersect at one line, not 1 point. So two planes intersect in exactly one line. Okay, numbers 3, 4, and 5 say to use the diagram to determine if the statement is true or false. Number 3 says the intersections of planes M and N is points B, E, and H. So remember that the planes, which is M and N this way, have to intersect at a line. So while these points are on that line, the intersection themselves is the line. So this is false, because the intersection is line BH or BE or EH. You can call it any of those. Number 4 says GH, and this should be line GH, lies in plane M. So plane M is my vertical plane, and GH is this line here. Okay, why these are dashed under here, that means that it's underneath that horizontal plane. But you can clearly say that both G and H are on plane M, and because both of those points lie on the line, then that the line that they are on also lies in that plane. So this is true. Number 5 says angle ABE and angle HED are vertical angles. So ABE is this angle here, and HED is this angle here. So if I extend the sides of this angle, I actually get this angle here. That would be its vertical angle, which means that this is false. Okay, now we're going to talk about your quiz. So your quiz is covering sections 2.1 to 2.4. 2.1 was simply just your patterns and your inductive reasoning. So we really only talked about 2 vocab terms in here: inductive reasoning and conjecture. Inductive reasoning is coming to a conclusion using patterns. So reasoning based on patterns. And then a conjecture is a conclusion you reach using inductive reasoning. So we talked about a couple of examples of inductive reasoning, or again, reasoning based on patterns. We talked about like something, for example, every third Wednesday, we have a half day. So this Wednesday is the third Wednesday of the month. So we would assume that we would have an early release day. So the inductive reasoning is that decision that we're using, that the pattern that every third Wednesday we have a day off. And then the conjecture itself is assuming that this Wednesday is an early release day. And then we talked about patterns in this section, patterns with shapes and with numbers. So you'll see something like that on your quiz where you'll have to determine the pattern. 2.2 was our conditional statements. So we'd start with an if-then statement, or P then Q, if P then Q, where the first part of our statement is our hypothesis and the second part is our conclusion. For example, if I sleep in, then I will be late to school. So the hypothesis here, remember, is not the word if, it's just what follows it. So it would be I sleep in. The conclusion is not the word then, but it's what follows the word then, which would I will be late to school. Then we talked about the converse. And the converse, we switch the order. So we take the hypothesis and the conclusion, switch it, which is if I am late to school, then I slept in. Then we talked about the inverse, and the inverse, we switch the change or negate what's there. So this would be not P followed by not Q. Something like, if I don't sleep in, then I won't be late for school. And then we had our contrapositive, which is, remember, the longest word. We have to do both with this one. The contrapositive is both the inverse and the converse. So it is not Q followed by not P. Switch the order so that it's, if I'm late, then I slept in, but negate it. If I am not late, then I did not sleep in. We also, in this section, had counter examples. Which is something that makes the hypothesis true, but conclusion false. So if I were to take my original statement, if I sleep in, then I will be late to school. Okay, sometimes you sleep in, but you still make it to school. Sometimes it has nothing to do with going to school. So this would be something, a counterexample would be, I slept in, but still made it on time. And then a biconditional statement can be made when both the if-then statement and the converse are true. So an example of this would be, if today is Monday, then tomorrow is Tuesday. So if that's my original if-then statement, then the converse would be, if tomorrow is Tuesday, then today is Monday. Both of these statements are true, which means a biconditional statement can be made from this. Today is Monday. If and only if tomorrow is Tuesday. Okay, then 2-3 was deductive reasoning. So we talked about two laws here, the law of detachment and the law of syllogism. The law of detachment said that if I had a true if-then statement and the if occurred, I assume the then occurs. So if lightning strikes near campus, then practice is canceled. So if this is my original statement and then something like lightning strikes the student parking lot, happens, then I can assume that practice is canceled. And that is based on the law of detachment. The law of syllogism needs two statements. So let's start with the same one. If lightning strikes near campus, then practice is canceled. If practice is canceled, then I have more time to study. So there's two statements being joined together by the same then. The then on one part is the if on the other. So what happens is, again, lightning strikes. Near campus or in the parking lot. Then I skip the part that joins them. I have more time to study. So again, syllogism, remember syllogism has two L's, the double L. It has double parts that are repeated. The then of one is the if of the other. And then you link the other two together. 2-4 was postulates and theorems. So we had a bunch of postulates in this section. And again, they have numbers, but the numbers are not what's important. What it says is important. So although it's called postulate 5, you'll not give that as an answer. Okay, if it asks you to explain which postulate it is or list the postulate that lets you lead to a conclusion, then you would say through any 2 points, there is exactly one line. Postulate 6 said a line contains at least 2 points. Postulate 7 said if two lines intersect, then their intersection is a point. Postulate 8 said through any 3 non-collinear points, there is exactly, which means no more and no less, one plane. Postulate 9 said a plane contains at least 3 non-collinear points. Postulate 10 says if 2 points are in a plane, then the line that contains them is in the plane. And postulate 11 says if 2 planes intersect, then their intersection is a line. So it's a lot of postulates in this section. You'll have to be able to either fill them in. If I give you part of it, fill the rest in, or using a diagram, explain using one of these if something's true or false. In this section, we also had the definition of a theorem, which is a statement that has to be proven. And then we talked about perpendicular figures, where you would want to make sure that in let's say you have a plane and then you have a line going through that plane. That would continue down underneath here. If that line is perpendicular to the plane, you'll see a little red mark. Then it's perpendicular to every line in that plane that intersects at that point. So if I have one that runs this way or one that runs this way, this green line is perpendicular to any of those individual lines. So if this is plane P and this is line L, then line L is perpendicular to plane P. If this is M and P, line L is also perpendicular to M, line L is perpendicular to N, and line L is perpendicular to P. Okay, you can use the remainder of the class to work on the quiz review that's on Canvas. You can also study using the Quizlet that's linked to the module underneath the quiz review as well. Tomorrow we'll go over any questions you've got in the quiz review, and then you'll take the quiz for 2.1 to 2.4. Have a great day.